Okay, so today we're going to learn about permutations and how we can use them in the real world. So for starters, let's talk about what a permutation is. A permutation is basically just an expression that determines the number of all possible orders of events. But one really important thing about permutations is that order matters. So here's what the expression looks like, and this exclamation mark is called a factorial, which denotes the products of decreasing positive whole numbers. So basically what that means is if this n was a 7, it would mean 7 times 6 times 5 times 4 and so on. Alright, now let's look at an example. So here we have 10 students are competing in a statistics Olympic in which the top 3 point scorers earn a prize. How many possible ways can the prize winners be arranged? So we can set up our expression. So our first value is this 10 right here, which is our total number of students competing in the Olympics. So we'll plug in 10 permutations, and then this R represents the number of ways they can be, or the top 3 point scorers. So we'll have a 3 right here. So then when we go to solve this, we plug it in. We do 10 factorials over 10 minus 3 factorials. So now we can see how these factorials kind of work out in a problem. We do 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1. All over, so we know 10 minus 3 is 7. So we'll have 7 factorials. 3 times 2 times 1. And we know that all of these are going to cancel out, which always is kind of nice. And then we multiply 10 times 9 times 8, which gives us 720. So that means that there are 720 ways the top 3 point scorers can be arranged from the 10 competing students. So if we look at another example, so here we have a thief steals an ATM card and must guess the correct PIN code that consists of 4 digits from 0 through 9 and must be entered in the correct order. How many attempts could the thief potentially face? So here we'll set up our expression again. Okay, and this time, so our value for this is going to be, since 0 through 9 is going to be 10, so 10 factorials over, and since it's a 4-digit combo, we will have 10 factorials minus 4 factorials. And again, it'll be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 10 minus 4 is 6. So we'll write this underneath in the denominator. And again, these will all end up canceling out, so we'll just make a little less work for ourselves. And now we'll multiply 10 times 9 times 8 times 7, which is 5,040. So that thief could potentially be facing 5,040 attempts at guessing the correct PIN. And that's how you can use permutations in the real world.